that's the good news.
Ja, und schon wartet der nächste Vortragende. Das ist Herr Professor Nicola Scafetta. Er ist Professor für Ozeanographie und Atmosphärenphysik in Neapel, an der Universität Neapel. Studiert hat er in Pisa und promoviert in Texas. Und er forscht zum Klimawandel, den Veränderungen in der Atmosphäre und den Ozeanen, dem Zusammenhang zwischen Sonnenaktivität und dem Klima sowie anderen geophysischen Phänomenen. Sein Arbeitsgebiet erstreckt sich auch auf theoretische und angewandte Statistik und nonlineare Modelle komplexer Prozesse. Herr Professor Scafetta veröffentlicht regelmäßig begutachtete Fachveröffentlichungen in einer Reihe von Fachgebieten wie Astronomie, Biologie, Klimatologie, Physik und Soziologie. Ja, wir freuen uns auf Ihren Vortrag.
Okay, thank you for the invitation. So I would like to talk to you about this topic, about the urban heat island and the bias in the climate network using a methodology that can be developed. Okay, so this is this one. So practically I use T minimum and the maximum temperature records. So let us a little bit introduce the problem here. First of all, you know about this, right? So this is what it is told to us. This is the IPCC last report, SR 1.5. So essentially, the claim here is that we need to avoid that the temperature rises at this level, that is 1.5 degrees above the pre-industrial level, because if we don't do that, if the warming will exceed this number, then there will be troubles, okay, a lot of troubles, okay, so we need to avoid these things. And these are the kind of troubles that may happen if the temperature continue to rise, right? So, and okay, so let us start. So this is what people would like to do. They would like to reduce the emission of CO2 so that the temperature will remain below this 1.5 degree of warming. And okay, so this is if the target is 2 degrees of warming from the pre-industrial time, yet this is what the countries will likely do. Okay, so this is what people need to do to reach the target, but this is what the countries will do. So how can we get this? So I don't know. In any case, this is what is happening right now in the world. These circles are the number of coal plant that are being built right now in the world. As you see in Europe and the United States, there is practically nothing, but see what is happening here. So there are around 1,000 coal plants that are being built right now in China, India, Indonesia, also Korea, Japan, and so on. So there is something strange. So I don't know how we can get the target if so many coal plants are being built here. So, okay, so in any case, we need to discuss these two records here. So we have the temperature record. This is the global surface temperature record. And these are the climate models that are used to interpret the data, okay? So when we have these two records, there are two questions that people should ask. The first question is the 0.9 Celsius global surface warming since the pre-industrial time reliable or not? So we have seen that there is this 0.9 warming since this period, this pre-industrial period, and then there has been this warming. So can we trust this warming or not? The second question is whether or not the models are reliable, okay? Because everything is done then using the models. So this scenario, the future scenario, this warming scenario that we see here are created using these models. So we need to understand whether or not the models are reliable. In this talk, I will address this topic. Okay? Tomorrow, I will address this other topic. So I will try to answer the two basic questions that we have. Okay, so let us see this question. So let us try to answer this question. Is the 0.9 Celsius global surface warming since 1859 and 1900 reliable or not? Okay, so first of all, of course, we know that the climate has always changed, so there is no problem here, okay? So it's changed a lot, and this is actually the climate change. This is CO2, so there is some contradiction between CO2 and the pattern in the climate system, but in any case, the problem is a little bit more complicated when we look at the system during the last 150 years. So what do we see here? So we have three records. The first record, this one, is the land record. This is the land temperature anomaly. The blue one is the ocean temperature anomaly, and the middle one is the average between the two. It's the average, a weighted average according to the percentage of land and ocean that we have. So what we can see here is that the land and the ocean were more or less similar here. And then during the last 50 years and so, there has been this divergence. Okay, so we have the ocean here and the land here. So the land warmed during the last 50, 60 years. The land warmed much more than the ocean. Okay, so we have a big difference here. But here there is not too much difference. The same thing happens if we take other records of the temperature. The red one is the land data from Berkeley Earth. And the ocean here, the ocean temperature is from the head SST. Okay, so also here we see this divergence between the two records, quite a strong divergence. So the ocean warmed much less than the land. At the beginning it started this way, and then there has been this divergence, okay? This is another record, okay, so we see always the same thing. So the land surface warms much more than the ocean surface. This is the GIS record, and this happened during the last 50 years, so on. Now, it's, of course, everybody knows that land and ocean have a different heat capacity, so it's possible that this difference that we observe is due simply to the fact that there is a different heat capacity between the ocean and the land. The land has a much lower heat capacity, so it will warm much faster than the ocean. So this can be the reason of this divergence. Yet, if we compare just the land region from different records, so these are the best satellites, GIS, the CRU, and this is the GHN record. So what we see is that the satellite, so now we are looking only on the land, the satellite's measurements appears to show less warming than the land, than the land measurements. So the land records seems to give more warming than the satellite's measurements. So what is happening here? And so what's happening is it's clear warming. There is this clear warming divergence, also using just land temperature records measured with the satellites versus the land stations. So what is happening here? Now, let us do an hypothesis. The hypothesis temperature records from land station are biased upward by urban heat island effects. So let us make this hypothesis, and let us check whether or not this is realistic. Now, what is the urban heat island effect? So we know that the cities, for several reasons that are here explained, get much warmer than the rural region. Okay, so there is essentially heat trapped inside the city produces heat and so on. So the city are much warmer than the surrounding region because they generate some kind, or in any case trap a lot of heat. And these are a kind of picture, so the cities are clearly much warmer than the surrounding, okay? So there is this urban heat island that develop around the cities. Now, these are a picture from California. So here there is a comparison between stations located close to the cities, so here, and other stations, this one that are more in rural regions. And what is happening here, what is being observed here is that the stations that are relatively close to big cities and so on get much warmer than this station here, where there is no warming recorded in the records. So this is a typical picture that is shown. So this is a warming of the cities, and this is the record from the rural region. So you see that there is a clear warming that is generated by the city. Okay, so this difference is due to the urban heat of the cities. So what happens? So why the urban heat island effect is a problem? It's a problem because the cities are not stationary, are dynamical bodies. They have grown a lot during the last 50, 60 years. So essentially what happens is the following. If a meteorological station is located in a rural or suburban area and this place is gradually urbanized in time, then this station records a warming due to the increasing urban heat that it experiences as the city grows around it. So if I have a station in one place and then the station is in a rural region, let us suppose, then there is a city that is growing around, that station will record a warming, even if the climate system remains perfectly constant. Okay, so this is something that is well known. Yet it is claimed that in the climate temperature records, urban heat island biases are corrected by homogenization approaches. So we have seen that the data are transformed, are treated in many ways to try to eliminate this effect and other problems. So they are cleaned, they are corrected in various ways, they are homogenized in various ways. So there is an attempt to eliminate this problem from the record. So in the original record that I show you, that is global surface temperature record, all these operations are done, so it is supposed that that record is cleaned by urban heat island effects. So there is this claim that is made. Yet homogenization is not a solution, because what is done essentially is to alter or correcting, they claim correcting a record in one place by using records also in other places, all right? So they do some kind of homogenization. But of course, if the records all these records are a little bit corrupted, so this is a little bit more corrupted, this less, this medium, and so on, if you take some kind of average, at the end you don't get clean water, but you get something that is a little bit dirty. So some urbanization effect will remain inside this algorithm that tries to eliminate the effect. But in reality, it does not really eliminate the effect. So it just spread it around, and there is the risk that the final product still contain a little bit of dirty. Okay, so it's not a real way of doing things. Okay, so how can we handle the problem? One way to handle the problem is to separate the station from rural to urban station, but in reality, this is not really efficient because even the rural station can be influenced by urban heat islands effects or something local, because it's a very strong effect. So, and it can spread around very easily, and also the urban area can be transformed in some way. So it's not really a solution. The solution comes, in my model, from the physics of the atmosphere. So this is a boundary layer structure of the atmosphere above a city. And what is observed is that there is a very big difference between the atmosphere, the physics of the atmosphere above a city during the daytime and during the nighttime. So practically what happens here is that the planetary boundary layer, this distance here, okay, this strata of air, during the day is much bigger than during the night. Okay, so that means that during the day, the heat is more concentrated around the city than during the night. The heat gets more trapped around the city than during the day, because this very high planetary boundary layer is diffuse heat more easily, so the heat will go up, and so it will go away. Instead, if this level is very low, then the heat can be actually trapped here and can actually be moved toward the suburban and rural area by the wind. So the wind will, there is this wind, it will warm up a little bit on the city and reach perhaps regions who are more rural, and therefore it will actually warm also this region. So there is some kind of effect like this. This effect of this heating is bigger, this effect is bigger during the night than during the day. So we need to distinguish day and night. And let us see what happens there. So OHI is stressed more during nighttime than during daytime. So we need to look not at the average temperature, but we need to look at the maximum and minimum temperature, because the maximum temperature is a measure of the daytime temperature, while the minimum temperature is a measure of the nighttime temperature. Okay, so we need to look not at the average record, but at the minimum and the maximum temperature, and see what happens there. This is a work that has been published a few months ago. So now I will talk about China, what happened in China. So this is the first study, then I will show you the world study, but now let us talk about, show you what happens in China. Why did I use China as a testing region? China is a very good testing region because you see here from this graph, the urban and rural population, how it changed during the last 70 years, okay? So practically you see that this is the rural population, this is the urban population. There has been a big change in population, a lot of urbanization occurred in China during the last 70 years. So we have these, the graph are the same percentage of population, the urban and rural area. So you see that practically now there are more people living in cities than in the countryside. So practically China had a huge, incredibly huge urbanization. So in Europe, we had the urbanization, okay? The urbanization doubled in this period, but in China became 10 times more. So it's something very, very big. So this is where the population is concentrated in China. This is density population, okay? So you see here from this picture, you see here from the color how fast the city grow in China. You see, this is Beijing. Beijing, it was like this, 1.7 million people. Now we have 20 million people, so something like that. So we had a huge amount increase of the population. These are, in China, it's a pretty good, diciamo, network. These are the network used for getting the temperature record in China, so it's not too bad. Quite. And so let us now look at the data. What happened in China from 1900 to now? So we have the maximum temperature, so the daytime temperature. We have the minimum temperature, so the nighttime temperature, and we have the mean temperature. That is what people usually look at. But as I told you, we need to look to this record, and we need to look to this record. So if we look at the minimum temperature, from this period to this period, the temperature rose 1.2 Celsius degree. Okay, so there is a rise of 1.2 Celsius degree. If we look at the maximum temperature, so the daytime temperature, it increased just 0.36 Celsius. Okay, so we have a big difference between night and day. So the average would be like this, but there is this huge difference. Now, what can we do with these records? We need to compare them with the predictions from the climate models that are then used for many things. And the models also give a minimum temperature, the average temperature, and a maximum temperature. And also in this case, the minimum temperature are predicted to grow a little bit more than the maximum temperature. So we have 0.94 Celsius degree and 0.75 Celsius degree. The average is 0.84 Celsius degree. Now, if you compare this number with this number, it's not too far. Okay, it's more or less correct. Okay, so a little bit different, but not a big deal. So there is a very small difference in the average temperature. But if you look at the maximum and the minimum temperature, the difference is huge. This is 1.2, this is 0.94, so it's 25% less. And this is 0.75, and this is 0.37, so it's almost half of it. So we have the average is almost good, but the minimum and the maximum temperature are completely different. Okay, so we have the models are telling one thing, and the data are telling a very different thing. Although the average temperature is almost the same, but the physics is contained in the minimum and the maximum, not in the average. Okay, so that is where we should look at. This is what happened in China. This is the observation. These are the models. The models, we have the T maximum. Is the difference between two periods. This period, so 1950 and 2010, this is the difference in temperature. You see that the models give something nearly homogeneous, all in China. Instead, the data are quite different. Okay, there are even situations where there has been registered cooling in China in some region between 1950 and 2010. So it's the reality looks quite different from the models. And this is what happened in the data. So we take the difference between T maximum and T minimum. So T minimum, the warming observed in T minimum minus the warming observed in T maximum between 1950 and 2010. And this is what we see. We see a lot of exceeding warming in this red region. So there is, so in this region we have almost T minimum 1.5 degree above T maximum warming. Okay, so there is a huge difference in degree. The dots that you see here are the cities, the main cities of China. So the localization of main cities of China are the dots here. This picture needs to be compared with this. This is the same calculation, is the difference between the warming of T minimum and T maximum between the same years, so 1950, 2010, obtained with the models, okay? So you see that there is a quite big difference. So here there is a slightly difference between T minimum and T maximum predicted by the models, but the reality is this one, where we have this concentration. Of course, okay, we can take the difference, so the bias between the temperature between the data and the models. This is the difference between practically this minus this, so we get the bias. So we get this kind of picture. So we see a lot of bias in this region here. We see a lot of bias in this region here or here. Okay, but this region are also the region with the greatest concentration of cities, as you can see here. Also here, there's a lot of cities here. Here there is almost nothing. Now let us see what happens here and what happens here, okay? So let us see what, so these are other pictures but are equivalent. These are the data, these are the models, data and models. I just changed the interval. So here is between 1960 and 2010. This is between 1970 and 2010. You see that there is the same pattern. So there is a huge concentration of bias here and here compared to the prediction of the models. Let us see this picture. Now I am dividing the data between the summer and the warm month from May to October and the cold month from November to April. And here we have the maximum temperature. This is the minimum temperature. This is interesting. So let us see at what happens during May to October in China on maximum temperature. You see that the temperature during the daily temperature did not change at all between this time and this time in China. Here, okay, during the winter it changed a little bit more. The minimum temperature grow in this way. But this is interesting because it appears that during, in China, during summer and during the day, there is no CO2 effect here. Practically in 60, 70 years, more than 70 years, there was been no warming at all. There was this cooling and warming, okay, that is observed everywhere in the world, but then this maximum and this max are practically the same. These are the prediction of the models. Again, the average is okay, but if we look at the minimum and the maximum temperature, these records, these are the predicted, are very different from the observation. So here there is this, and here we have this warming, okay? Here there is this warming, so here we have this. So they are very different, very different. There are the bias that we observe. These are the observations, these are the models. So this is a difference. We get a huge amount of difference compared to the models. So, and these are months by months. These are the models, these are the data, huge difference. So what is happening here? So practically, the fact that there is a so big difference between the minimum and the maximum temperature in China, much more than what the models predict, in my opinion, that implies that, there is some problem there. Of course, one can claim that the models are wrong for several reasons, but if we assume that the models are correct, which is what the IPCC assumes, we need to conclude that the temperature record has a problem. And the problem might be that there is urban heat island that remains inside the record even after the homogenization of the records. And this picture explains well the reason. So let us look at what happened in this region that was very red in the picture that I show you. If I zoom this region, I get this. If I zoom this, I get this. If I zoom this, I get this. So these little dots that you see here are a lot of cities. So practically all this region that was red, very red, is filled with a lot of towns little towns at 1, 2, 3 kilometers of distance, one from the other, that has been built in the last 50 years. So this was very rural. Now it has become suburban, okay? So practically we have thousands of kilometers practically filled with little town. So it's obvious that the entire network here is biased by some kind of urban heat island effect, and there is no method to clean the temperature records from this heat. Because, of course, this warms, so also this region will warm in the middle. So it's obvious that all region. This region here was the one that has practically no effect, no warming, and you see that it's extremely green. There are no there is a big city here, but there are no cities, towns all around. There are just houses around. There are not little town like this, no? There is just a big city here and nothing else. So everything else is rural, even if there are little houses all around. But no cities, not little town all around. So here you can easily separate urban from rural, but here you cannot. So practically in China, there is a lot of urban heat island effect in the record. But that means that the original record that I show you is biased. Okay, the original record that I show you is biased, warm, because the urban heat island effect has not been cleaned as it was claimed to be. So there was surely less warming in China. And this record here is very curious, because it's very curious that during summer, the hot months, Tmax in China did not grow at all in 70 years. So it seems that CO2 does not work during summer and during day in China. Okay? So that is the situation. There might be some other problem related to the pollution in China and so on that may have an effect, but the pollution will reduce the heat, so we might have an effect, equivalent effect on night and days, but not make a difference between night and day so big. Okay, but what is happening in the world? So the problem of China in reality exists all around the world, okay? So not just here. So let us see what happens in the world. These are the data, the same data. We have showed these things before, this area before. This is what happens in the rest of the world. These are the models, the prediction of the models. You see that there is a big difference between the models and the data. These are a picture of the data, okay? So you see here these red spots. Oh, you see this color here, this color here, this color here, here. You see this color here. Oh, you see something here. So you can see something interesting. There is all this region, quite red. These are regions that grow a lot on this China region. In Europe, the things are, depends. Here in Germany, perhaps there is no big deal, but in the rest of Europe, here there is some problem. Here in England and so. There is some problem here. There are big cities here, somehow. There is big problem here. In the United States, there are problems here, something here. Here, there may be some other reason, because there are some other mechanism in place, because this hot spot here, there are no cities here, big cities, so there may be some other effect, but urban heat island effect can be also caused by very small town. If they grow and there is the station there, so it may get some warming. So there is some dark blue dots. You see, these blue dots are due. These are in the desertic region. The desertic region, usually the urban heat island, the urban effect is not a warming, but it's a cooling. It's the opposite, so there is some problem. Here there has been a lot of deforestation, a change the albedo. So you can see a lot of stuff like that. So there was a cooling because there was a deforestation. And so you can see something, but the records has some bias. These are the bias that we have seen. And practically, at the world record, it's likely that there is some part of the warming that has been registered in the data, that 0.9 Celsius that has been registered in the data, may be partially due to some problem in the handling the data, so related to urbanization and other effects, which might not be climatic, so maybe due to deforestation, maybe due to other effects like that. So it's not a warming induced by greenhouse gases or something else. So there are problems in the land station, and perhaps 10–20% of the warming is fake. No, it's not really climatic. It's due to something else, so to problems in the data. Now, let us look at one place where the urban heat island effect probably does not exist, and this is Greenland. In Greenland, there are 30–40,000 people living in very small town, which are this one. So probably here the population has not grown too much during the last 50 years. So in any case, the cities are very few and they are very small. There are few hundred people, or maximum, the biggest one has 15,000 people. So they are very, very small town. So we have just 3 cities above 1,000 people. So it's something extremely small. So we have few hundred people for each town. So probably in this region, very large region, there is no urban heat island effect. So what we see here, the red line is the climate record, the temperature of Greenland, as is recorded in Greenland. This is and the blue one is the models, the models, okay? The models that predict this warming. So from this period to this period, you see that the data are here and the models are here. So practically, this is 0.7, and this is about 1.5. So since this period, the models have predicted nearly double of the warming observed in Greenland. So what does this mean? What does this mean? It means that these models are clearly wrong, because they are overestimating greatly the warming in this region. Okay, so according to the model, the CO2 has produced this warming, had to produce this warming, but less than half is observed. Okay, so we see this cooling that we see also in China, this cooling, and then this warming. So this cooling, warming that we see all around the world, and then the warming. So, but the model don't have this cooling. They don't have this cooling. They go up in this way due to CO2, following the CO2 production, emissions, the data in this region. So practically what is happening here? Several evidence show that the temperature climatic land records are likely biased by urban heat island effects, which has not been efficiently filtered by homogenization approaches. The claim that the 20th century warming is likely overestimated by a few tenths of a degree. Greenland suggests that models overestimated the warming since the 40s by a factor of 2. So this means that we need to look at the temperature record that we have, because there might be problems there. Too much warming has been inside those records, maybe a little bit less. There was a warming because we have other evidences that a global warming existed. We have, for example, the data from the ocean. The ocean has warmed, so the warming occurred, but probably a little bit less than what the records that we have, because they were not able to filter out local effects that have nothing to do with climatic effect, like the urban heat island. And the models were calibrated to get the warming observed But if the real warming was a little bit less, the models are misinterpreting the data. Of course, they are overestimating the effect of the greenhouse gases, like CO2, the effect of CO2, and so on. And so the problem is very open, okay? The problem is very open, and so we need to look again, even at the temperature record. We cannot fully trust that trends. I finished.
Recht herzlichen Dank. Und jetzt folgen die Fragen.
Robert Lechner-Schobel ist mein Name. Professor Piantelli, thank you very much for this great presentation. And the effects that you explained, the warming in urban areas, isn't the same effect applicable also for large wind parks? I remember the largest wind park in Texas, the measurement value in the ground within 10 years, 0.73 centigrade warming. And if a study from the Massachusetts Institute of Technology shows 10% wind energy is 1 centigrade warming globally. And also what I think Germany, wind farms up to 100 kilometers a distance from the coast, will this not create a huge amount of warming? And is it the right way what the Panic Institute for Climate Research says? More windmills to fight against this warming?
Yeah, I don't know now the details that you're talking about, but of course every source of heating in the surface will be considered urban heat island effect. So there will be the same effect, more or less. Of course, the cities are very big objects, so there the effect will be more relevant. So it's important also to know where the station, the meteorological station is located, because of course it depends on so we have those data, and so it's very important to determine where those station is. But the warm is not just local. So I show you that the wind is able to move the warm air from one region. So if this is the city and this is a countryside, I cannot say that here there is no urban heat island effect, because the wind takes the warm air from here and a little bit it moves here. So a little bit of warming is spread around, and that is not a climatic warming. It's a warming. It's a warming. It's because the temperature measure a warming, but it's not due to greenhouse gases. It has a different origin. The models don't have this mechanism, and therefore they try to interpret the warming due to just the greenhouse gases, and that is misleading, because they end up by overestimating the warming. That is the problem. And we get a lot of evidences of this overestimation. And tomorrow I will talk more about that. So there are huge evidence that the anthropogenic global warming due to the emissions is overestimated. Then there are other warming sources, but it's not climatic, it's due to other factors.
Hello. One question here. Javier Corripio from Meteo Exploration here. Thank you for highlighting a very important process that I think has been neglected in the evaluation of temperature. And I have a couple...
Excuse me, I am not able... Okay, repeat the...
Yeah, thank you for highlighting an important process that I think it has been neglected in the evaluation of temperature. And I have two questions. You mentioned the boundary layer at night, but sometimes, well, most of the times, minimum temperature is constrained by dew point temperature, which is related to moist content, to humidity. And there's a lot of processes in cities that inject moist into the atmosphere. So how important you think that may be? And then the second question, do you have an idea of the bias introduced by the homogenization? You talk a few tenths of a degree for the total thing, but the homogenization itself, how much it could be. Because Kutsuyani talks about maybe half of the total warming.
Well, I don't have a quantification of the effect. Totally, it's not easy to quantify. I cannot say that there is a bias, because then to quantify the effect, we need to really look to regions where there is no urban heat island effect. It must be a very big region. So I show you the example of Greenland, but we need still to look at other regions. So that's just an example. If we suppose that Greenland is a good testing region, we have that, and we suppose the models are correct, because the model, they try to interpret the warming, right? So we got that the models double the warming observed in Greenland. And therefore, it is possible that this urban heat island effect might be even have contributed double, so maybe half of the warming could be related to it. But I don't feel that as so simple, because there are blue region, so there is more I need to work more on those data to quantify exactly. But surely there is a problem, because in many regions of the world, there is a very large there is a warming that appears to be partially 20, 30% due to urbanization effect that has not been cleaned, because if it were cleaned, we could not see this big difference between minimum and maximum temperature, because both temperatures are cleaned, but still the effect is still there. So I think that is an open problem. It's not solved. I did not solve. I just show that there is a problem, and that problem needs to be addressed. And then that problem fits with many other research claiming that the emissions, human emission, the climatic effect of human emission is overestimated, because the models are giving too much warming, and so they are not getting the data. They're not getting that cooling from the 40s to the 70s, and that is a big problem for these models. So, and then many other things. So it's an open problem, but just I show you that there is a problem that needs to be addressed, because what I've done is not perfect, let us say. And for the other questions, yes, there are many effects that the city do, including adding a lot of water vapor. And in particular, I think in the desertic region, there is a lot of water vapor, and that may have the cooling effect instead of warming effect, compared to the desertic region that is surrounding the situation. So the water will keep a little bit cooler the system. So there is, of course, many things that needs to be understood well. But right now, this is research that is going on. Okay?
Professor Scafetta,
Yes.
I have a question concerning the reliability of the measurements, especially in the first half of the 20th century. Because I doubt that in Central Asia there was a grid of stations that gives us reliable temperatures. Same over oceans.
Yes.
We know that in the old days there have been weather ships who made observations, but they were so rare that nobody can tell me that they have reliable temperature measurements.
Yeah.
First. Second, average temperatures, in my opinion, is not a very valuable method, because I have been in northern China, in Beijing, for a couple of times, and in winter it was bitterly cold, with temperatures of below -20, and in summer it was over 40 sometimes, for Celsius, and with a humidity of 90%. So if you make an average temperature, let's say like 10%, in my opinion, there's no valuable statement of this.
Yeah, yeah. So that is, about the first questions, the reliability of the records before 1950, I agree that there are problems because there are few stations, but in my analysis, I started from 1950 to today. So I am not using the data before 1950. So I am using the data from after the war, so 1950 and so on. So in any case, I am assuming what they assume. So the center that provided the global surface temperature, that is what is used, they claim those data are sufficiently reliable. So I am not questioning what they do say. If they say that those data is what we have, and that is the reconstruction that we have, so I start with that hypothesis. Okay, I start believing them. Then, of course, there are many other problems on this, but I assume they are right, they are good, they did their best for getting the data, but still, those data have problems, and therefore needs to be addressed. I have problems during the last 50, 60 years when the cities grow so much all around the world, in particular in this country, not in Europe, but in the other countries of the world, they grow so much. And and those problems suggest that there is still some local warming, like urban heat island effect, that is that remain in those data. So those data they provided do not really tell us the climate change. They are telling us something that is a mixing between climate change and the local warming that has not been cleaned out. And therefore, it's a problem that needs to be still investigated and solved. So this is my answer to, I don't know if I sufficiently answer your question, but I agree with you that there are other problems due to the geographical distribution of the data and so on, but that would be a different issue than this one.
Herzlichen Dank.
Thank you very much.